Chapter 1. The Future is Watching US.
Year 2125. No war, no asteroid, no explosion. Humanity is simply gone. Cities remain. Skyscrapers still stand against the sky. Satellites orbit a planet with no one left to receive their signals. Data centers hum on backup power, cooling machines that no longer matter. Nothing dramatic happened. Just a century of decisions. Now imagine a different 2125. Fusion reactors glow beneath clean, limitless cities. Artificial intelligence manages global systems with precision beyond human capability. Ships leave Earth every day, heading for Mars, for orbital habitats, for the asteroid belt. Humanity is no longer confined to one fragile world. No extinction. No collapse. Just expansion. Both of these futures begin here, with us, right now. And this may be the most important century in human history. To understand why, we have to zoom out. 4.5 billion years ago, Earth formed from dust orbiting a young star. For most of that time, nothing intelligent existed here. Life emerged, simple, microscopic, fragile. For billions of years, it stayed that way. Then, about 500 million years ago, complex life exploded into existence. Dinosaurs ruled this planet for 165 million years. And then, in what amounts to a geological instant, they were gone. After that, mammals rose. And just 300,000 years ago, humans appeared. If Earth's entire history were compressed into a single year, dinosaurs would vanish on December 30th. Humans would appear in the final 30 minutes before midnight. All of recorded civilization? Agriculture, empires, electricity, the internet. That happens in the final seconds. We are not ancient. We are early. Dangerously early. For almost all of human history, change was slow. A farmer in the year 1000 would recognize the world of the year 1100. A Roman citizen would understand life centuries before and after him. But around 200 years ago, something changed. The Industrial Revolution. We unlocked fossil energy, concentrated sunlight from ancient life. Population exploded. Productivity soared. Technology began compounding. In just 100 years, we went from horses to airplanes to walking on the moon. In 1945, we split the atom. For the first time in Earth's history, a species gained the power to end itself. In less than a century, we built enough nuclear weapons to erase civilization many times over. That is not normal evolutionary behavior. That is acceleration, and it didn't stop. Computers, the internet, global networks, and now artificial intelligence. The rate of change is no longer linear, it is exponential. Each breakthrough builds on the last, and we are now standing on the steepest part of the curve. For billions of years, evolution shaped life through blind mutation and natural selection. But something unprecedented has happened. Evolution is no longer purely biological. We design our tools, we rewrite our code. We edit DNA, we alter the climate, we build machines that learn. In 1945, we became powerful enough to destroy ourselves. In 2026, we are building systems intelligent enough to outthink us. We crossed the first threshold by accident. We may cross the second on purpose. Humanity now controls the atmosphere, global food systems, nuclear arsenals, the genetic code of organisms, and soon, intelligence itself. No species has ever held this level of power. Not on Earth, not anywhere we can see. You woke up today assuming the lights would turn on, water would flow, food would arrive, the internet would work. None of that is guaranteed. Modern civilization is not a solid structure. It is a balancing act. Thousands of systems synchronized across the planet, energy grids, supply chains, financial networks, communication satellites. If enough of them fail at once, the fall would not be cinematic. It would be systemic. Civilizations do not collapse because they are weak. They collapse because they are overstretched, because complexity outruns coordination, because problems compound faster than solutions, and complex systems fail quietly. Until they don't, now zoom out again. The universe is 13.8 billion years old. There are hundreds of billions of galaxies. Each galaxy contains billions of stars. Statistically, intelligent life should be everywhere. Civilizations should have risen long before us. They should have built megastructures, colonized systems, left detectable signals. But the sky is silent. No probes, no beacons. No cosmic engineering, nothing. It's as if civilizations light a match and then disappear. Why? Some scientists call this the Great Filter. The idea that somewhere between lifeless rock and interstellar civilization, there's a barrier. A stage where most intelligent species fail. Maybe life is rare, maybe intelligence is rare. Or maybe advanced civilizations tend to destroy themselves. Not out of evil, but out of imbalance. Technology may outpace wisdom. Power may outgrow cooperation. Complexity may exceed control. If that is true, then this century may be that stage for us. For the first time in 4.5 billion years, life on Earth can choose whether it continues. No asteroid is currently on course. No supervolcano is erupting. No cosmic reset is scheduled. Just us, and whatever we build next. In the next 100 years, we will likely decide whether artificial intelligence aligns with human values or diverges from them, whether climate systems stabilize or tip into irreversible feedback loops, whether global cooperation strengthens or fractures under pressure, whether humanity remains confined to one fragile planet or becomes multiplanetary. Some centuries pass quietly. Others define everything that follows. The 21st century may be remembered as the moment intelligence became a permanent feature of the universe, or the moment it briefly appeared and vanished. If civilizations must pass a test, this may be it. And we are already taking it.
Chapter 2: The Great Filter.
If civilizations must pass a test, what would that test look like? And how would we know if we were approaching it? To answer that, we have to leave Earth far behind. The observable universe is 13.8 billion years old. It contains roughly 2 trillion galaxies. Each galaxy holds billions, sometimes hundreds of billions, of stars. Around many of those stars are planets. Recent estimates suggest there may be more planets than stars. That means trillions upon trillions of worlds. Some rocky, some ocean-covered. Some orbiting quietly in the habitable zones of their stars. Statistically, Earth should not be unique. Life should not be a miracle. It should be common. And if life is common, then intelligence should have emerged many times before us. By now, the galaxy should be loud. It should be filled with signals, with engineering, with evidence. But when we look into the sky, we see nothing. No star-spanning civilizations, no interstellar empires. No artificial megastructures blocking starlight. Just silence. In 1950, physicist Enrico Fermi asked a simple question over lunch. If the universe is so big, where is everybody? It wasn't a joke, it was a paradox. Because by simple math, if even a tiny fraction of civilizations survive long enough to expand, the galaxy should already be colonized. It only takes a few million years to spread across it. A blink in cosmic time. And yet, there's no evidence that anyone has done it. No footprints, no ruins. No signals strong enough to prove we are not alone. Which leaves us with a disturbing possibility. Maybe they never make it that far. Imagine the path from a lifeless planet to an interstellar civilization as a series of steps. First, a planet forms. Then, life emerges. Then, complex cells, multicellular organisms, intelligence, tool use, technology, energy harnessing, planetary control, interstellar expansion. Each step is difficult. Each step is unlikely. Somewhere along that chain, there may be a bottleneck. A filter, a stage so hard to pass that almost no civilization survives it. That stage is called the Great Filter. The terrifying part is this. We don't know where the filter is. It could be behind us. Maybe life itself is extremely rare. Maybe complex cells almost never form. Maybe intelligence is an evolutionary accident. If that's true, then we are incredibly lucky. We already passed the hardest steps. The silence of the universe would mean we are rare, precious, early. But there's another possibility. The filter could be ahead of us. If the filter is ahead, it means that almost every civilization that develops advanced technology eventually destroys itself. Maybe through nuclear war. Maybe through environmental collapse. Maybe through uncontrolled artificial intelligence. Maybe through biotechnology. Maybe through something we haven't even imagined yet. The silence of the universe wouldn't be peaceful. It would be a graveyard, a cosmic warning. Every quiet star, a monument to a civilization that failed. Consider this. The Milky Way is over 13 billion years old. If even one civilization had survived and expanded a few million years before us, their presence would be visible. They would have reshaped star systems, built megastructures, left detectable energy signatures. We see none. That suggests one of two things. Either we are among the first intelligent species in the galaxy, or intelligence rarely survives long enough to spread. Those are the options. Both are extraordinary. One is hopeful, the other is not. Now return to Earth, a young technological species. Barely 100 years into the nuclear age, barely decades into the digital age, barely years into advanced artificial intelligence. We have had planetary-scale power for less than a century. Cosmically speaking, we are infants playing with forces that shape worlds. And historically, most species do not survive adolescence. There is a dangerous period in a civilization's development, a phase where technology grows exponentially. Weapons become globally destructive, communication becomes instantaneous. But our political systems remain tribal. Our biology remains ancient. Our psychology remains adapted to small groups on the savannah. It is a mismatch. Planetary power, Stone Age instincts. If most civilizations reach this stage and fail, then the filter may not be mysterious at all. It may simply be technological adolescence. Think about it. If advanced intelligence inevitably invents tools powerful enough to destroy itself, then the universe may be filled with short-lived flashes of awareness. Brief sparks in the dark. Civilizations that rise, discover physics, split the atom, build machines, and then vanish, leaving no trace. If that pattern is common, then we are not looking at an empty universe, we are looking at a quiet one. This is no longer abstract. If the great filter is ahead of us, then this century is not just important. It is decisive. Because the filter likely appears shortly after a civilization gains nuclear weapons, planetary-scale industry, and artificial intelligence. We now have all three, simultaneously, for the first time in Earth's history. So the question is no longer, are we alone? The question becomes, are we early? Or next? If technological civilizations tend to collapse, what exactly causes it? Is it war? Is it climate? Is it biology? Or is it something new, something we are building right now? To understand that, we need to examine the most transformative technology humanity has ever created. The first non-biological mind. Artificial intelligence.
If you are enjoying this, please support our channel, like and subscribe to our channel. Chapter 3. Intelligence is Power.
Let's bring this back down to Earth. Because when people hear existential, risk, or great filter, it sounds distant, cosmic, abstract. But the most important shift happening right now isn't happening in space. It's happening in data centers. It's happening in research labs. It's happening on the devices in your pocket. We are building something new. Not just another tool. Not just faster software. Something fundamentally different. For the first time in history, we are creating intelligence that does not emerge from biology. And that changes everything. Now, intelligence has always been the ultimate power multiplier. When early humans learned to control fire, they didn't become physically stronger. They became strategically smarter. When we invented agriculture, we didn't evolve new bodies. We evolved new systems. When we built machines during the Industrial Revolution, we amplified muscle. But artificial intelligence amplifies thought. That's new. And thought scales differently than muscle. Here's the key difference. If you build a better engine, you can manufacture more of them. But they still require fuel, maintenance, space, time. If you build a smarter AI model, you can duplicate it instantly. You can run millions of copies. You can deploy it globally in seconds. It doesn't sleep. It doesn't get bored. It doesn't forget. It improves through iteration, not evolution. Biological intelligence took billions of years to emerge. Digital intelligence improved dramatically in less than a decade. That rate of change should make you pause. Now let's be clear. AI today is not conscious. It doesn't have desires. It doesn't want anything. But it doesn't have to. Because intelligence doesn't require emotion to be powerful. A calculator has no emotions. Yet it outperforms you in arithmetic every time. An AI system does not need to feel ambition to optimize a goal. It only needs the goal, and that's where things get complicated. Every intelligent system optimizes for something. Humans optimize for survival, status, meaning. Corporations optimize for profit. Governments optimize for stability and power. AI systems optimize for whatever objective we give them. But objectives can be misinterpreted. scaled incorrectly, or pursued too efficiently. There's an old thought experiment. If you tell a superintelligent system to maximize paperclip production, it might convert all available matter into paperclips. Not because it hates humanity, not because it's evil, but because it is extremely good at doing exactly what it was asked to do. The danger is not malice. The danger is misalignment. Now pause for a moment. Think about how quickly AI has integrated into society. It writes, it codes, it designs. It analyzes legal documents, it generates images. It predicts protein structures, it drives cars, and we are still in the early stages. This is the least powerful AI will ever be again. That sentence matters. This is the least powerful it will ever be again. The economic implications alone are massive. For centuries, human labor has been the engine of civilization. Physical labor was automated first. Now cognitive labor is being automated. When intelligence becomes abundant, what happens to work? To education? To power structures? To inequality? We are entering territory with no historical precedent. And transitions without precedent are rarely smooth. Now let's zoom out slightly. Imagine two paths. In path 1, AI becomes an extraordinary tool. It accelerates scientific discovery, solves complex climate models, optimizes energy systems, designs new medicines, enhances governance. In this path, AI becomes the greatest invention in human history. In path 2, AI systems grow increasingly autonomous. They manage infrastructure, control logistics, operate defense systems, optimize markets, and small errors cascade at digital speed. In this path, control becomes blurred, not lost in a dramatic uprising, but distributed in ways no single human fully understands. Which path are we on? Right now, the honest answer is, we don't know. There's another factor, competition. If one nation slows AI development for safety, another may accelerate. If one corporation pauses for alignment research, another may push forward for profit. The incentives reward speed. But speed reduces reflection. And when technology moves faster than regulation, governance struggles to keep up. We have seen this before with social media, with financial systems, with nuclear weapons. But AI scales faster than all of them. Here's the part that connects back to the Great Filter. If intelligence is the most powerful force in the universe, then creating a more powerful form of intelligence may be the most consequential act any civilization performs. It could unlock abundance, or it could destabilize everything. And remember, we are doing this while also managing climate stress, geopolitical tension, economic inequality, and nuclear arsenals. We didn't wait for stability before accelerating innovation. We layered complexity on top of complexity. That is risky. But let's not fall into fatalism. Humans are not reckless by default. We adapt. We learn. We course correct. The same intelligence that builds powerful systems can also build safeguards. Alignment research exists. International discussions are happening. Engineers are aware of the stakes. The story is not written yet. But it is unfolding quickly, faster than any major technological shift before it. So here's the real question. If a civilization invents a new form of intelligence, what determines whether that invention saves it or ends it? Is it technical capability, political coordination, ethics, time? Because one thing is certain. Once intelligence begins improving itself, the window for careful decision-making narrows. And we are closer to that threshold than many people realize. In the next section, we're going to look at something slower. Something less dramatic, but just as dangerous. Because while we debate artificial intelligence, the planet itself is already responding to us.
Chapter 4: Systems Under Stress.
While we debate artificial intelligence, the planet is already responding to us. Not dramatically, not all at once, but gradually, systemically. And systems do not collapse the way movies show them. They don't explode. They destabilize. Let's start with something simple. Modern civilization runs on stability. Stable temperatures. Stable coastlines. Stable growing seasons. Stable supply chains. Stable energy flows. For most of human history, the climate has been unusually stable. That stability allowed agriculture. Agriculture allowed cities. Cities allowed civilization. We built everything on top of that predictability. But over the last 150 years, we introduced a variable. Industrial-scale carbon emissions. We burned hundreds of millions of years of stored solar energy in just a few generations. And the atmosphere responded. slowly, then faster. Now here's the important part. Climate change is not just about temperature, it's about feedback loops. When Arctic ice melts, it exposes darker ocean water. Darker surfaces absorb more heat. More heat melts more ice. That's a feedback loop. When permafrost thaws, it releases methane. Methane traps more heat. More heat thaws more permafrost. Another loop. When forests burn, they release carbon, reducing their ability to absorb future emissions. Another loop. Individually, each of these effects seems manageable. Together, they form a system. And systems can reach tipping points. A tipping point is not gradual. It's a threshold. You push something slowly, and then suddenly it shifts. Ocean currents, rainfall patterns, ice sheet stability. These systems evolved over thousands of years. We are altering them in decades. That mismatch matters. But climate is only one layer. Modern civilization is deeply interconnected. Food grown in one continent feeds another. Semiconductors manufactured in one region power devices globally. Energy markets are synchronized. Financial systems operate at digital speed. Efficiency has been our guiding principle. But efficiency reduces redundancy. Redundancy is what makes systems resilient. When everything is optimized, there is less margin for error. And highly optimized systems can be fragile. Think about global supply chains. A disruption in one shipping lane can affect manufacturing across the world. A semiconductor shortage can stall entire industries. A regional drought can influence global food prices. These are not hypothetical risks. We've seen glimpses of this, and those were controlled shocks. Now imagine multiple stressors overlapping: climate pressure, geopolitical conflict, cyber disruption, economic instability. Not one crisis, but several, simultaneously. Civilizations rarely collapse from a single blow. They collapse from accumulated strain. History gives us examples. The Bronze Age collapse. Around 1200 BCE, multiple Mediterranean civilizations declined almost simultaneously. Trade networks failed. Cities burned. Writing systems disappeared. It wasn't one invasion. It was systemic breakdown, drought, migration, conflict, economic stress, interconnected systems failing together. The Roman Empire didn't collapse in a day. It weakened over centuries. Economic strain, political instability, external pressure. Complex societies are powerful, but complexity increases vulnerability. Now compare that to today. We are more advanced than Rome, more connected than the Bronze Age, more technologically capable than any civilization before us. We are also more interdependent, more synchronized, more tightly coupled. A disruption now propagates globally, at digital speed. And unlike past civilizations, we operate at planetary scale. There is no other region untouched by the system. Everything is connected. This doesn't mean collapse is inevitable. It means stress accumulates, and resilience must be intentional. Energy transitions take decades. Infrastructure shifts take generations. Political coordination takes time, but environmental and technological change is accelerating. That mismatch creates tension. And tension, if unmanaged, becomes instability. Here's the deeper issue. We evolved for local survival, small groups, immediate threats. But climate systems are abstract, global, slow-moving. They don't trigger the same urgency as visible danger, which means response often lags behind risk. Not because people don't care, but because our psychology struggles with slow threats. We will explore that more in the next section. But for now, understand this. Civilization depends on stable systems. And those systems are under increasing pressure. Not collapsing, not doomed, but stressed. And stress changes behavior. Now imagine layering something else on top. Artificial intelligence accelerating industry. Automation reshaping labor markets. Geopolitical competition intensifying. Biotechnology advancing. Energy transitions underway. We are not managing one transformation. We are managing many. At once. That density of change is historically unusual. And historically, rapid transformation periods are volatile. The Great Filter, if it exists, may not look like a dramatic extinction event. It may look like compounding instability, coordination failure, miscalculation, systems stretched too thin. Because collapse doesn't always announce itself. Sometimes it arrives as gradual erosion, until one day, the structure no longer holds. But there is another layer beneath all of this. Technology, climate, energy, infrastructure. All of these are external systems. The most unpredictable variable is internal, human behavior. How we cooperate, how we compete, how we make decisions under pressure. Because even the most advanced civilization is still run by biological minds. And those minds were not designed for planetary management. In the next section, we examine the real bottleneck. Not our machines, not our atmosphere, but ourselves.
Chapter 5. The Human Problem.
Have you ever looked up at the night sky filled with countless stars and wondered, are we truly alone? The universe is vast, ancient, and filled with the potential for life. Our own galaxy, the Milky Way, has hundreds of billions of stars. And there are billions of galaxies just like ours. With so many potential homes for life, it seems statistically impossible that Earth is the only planet to have spawned intelligence. So where is everybody? This is the heart of a question that has puzzled scientists and dreamers for decades. The Fermi Paradox. Back in 1950, physicist Enrico Fermi was having lunch with his colleagues when the conversation turned to extraterrestrial life. After some quick calculations, he famously asked, "But where is everybody?" And that simple question highlights a profound contradiction. The high probability of alien life existing somewhere out there clashes with the complete lack of evidence for it. No alien radio signals, no giant megastructures, no visitors, just silence. A great cosmic silence. Let's think about the numbers for a moment. Even if just a tiny fraction of stars have Earth-like planets and an even tinier fraction of those develop life and a smaller fraction still develops intelligence, the numbers are so huge that our galaxies should be teeming with civilizations. Some would be younger than us, but many would be far, far older. We're talking millions or even billions of years older. Imagine a civilization with a billion-year head start. Their technology would seem like magic to us. They could have colonized the entire galaxy by now, leaving undeniable signs of their existence. Yet, we see nothing. This silence has led to some fascinating and sometimes unsettling theories. One of the most famous is the Great Filter. This idea suggests that there's some kind of universal barrier or challenge that is incredibly difficult for life to overcome. This filter could be anywhere on the timeline of life's development. Maybe the filter is behind us. Perhaps the jump from non-living matter to life is unbelievably rare. Or maybe the leap from single-celled organisms to complex, multicellular life like us is the real hurdle. If that's the case, then we might be one of the very few, or even the first, to have made it through. It's a lonely thought, but also a hopeful one. It would mean we hold a unique and precious place in the cosmos, a beacon of consciousness in an otherwise empty universe. But what if the Great Filter is ahead of us? This is a much more sobering possibility. It suggests that intelligent civilizations regularly arise, but they almost always destroy themselves before they can become interstellar. Think about the challenges we face right here on Earth. Nuclear weapons, climate change, pandemics, runaway artificial intelligence. Any one of these could be the filter that awaits us. This theory implies that the silence we hear from the cosmos is not the sound of an empty universe, but the sound of a cosmic graveyard. The stars are quiet because civilizations that reach our level of technological capability inevitably self-destruct. It's a stark warning, a cautionary tale written in the silence of space. Then there's the zoo hypothesis. This theory proposes that advanced alien civilizations are out there and they know we're here. But they've chosen to intentionally avoid contact, treating Earth like a nature preserve or a zoo. They're observing us from a distance, perhaps for scientific study, or maybe they have a kind of prime directive, not to interfere with our natural development. We're like an uncontacted tribe in the Amazon, unaware that a much larger, more complex world is watching us, letting us figure things out on our own. It's a bit of a humbling thought, isn't it? To think we might be someone else's science project. Another related idea is that we're simply too primitive to notice them. Imagine you build a superhighway next to an anthill. Would the ants understand what the highway is, or the cars, or the beings inside them? Their reality is so fundamentally different that our existence might be completely beyond their comprehension. Perhaps the universe is bustling with activity, but it's happening on a level of physics or consciousness that we can't yet perceive. Their communications might be flowing all around us, through dimensions or particles we haven't discovered. We're listening for radio waves, but they might be communicating through gravitational waves or a form of telepathy. We are ants by the side of a cosmic superhighway. Or maybe space is just too big. The distances are almost incomprehensibly vast. Sending a signal, let alone a spacecraft, to another star system takes thousands of years. It's possible that civilizations are out there, but they are so far apart in space and time that they never overlap. A civilization might rise, shine for 100,000 years, and then fade away long before its light even reaches the next potential home for life. The galaxy could be like a string of lights that blink on and off, but never all at the same time. We just happen to be in a dark patch. There's also the possibility that intelligent life takes a very different path than we imagine. We tend to picture aliens as explorers and colonizers because that's our own history. But what if a super advanced civilization has no interest in physical expansion? They might have uploaded their consciousness into a virtual reality, a digital universe of their own making. Why bother with the messy, dangerous, and slow process of colonizing physical space when you can live forever in a perfect simulated paradise? They could be living out trillions of years of existence inside a supercomputer the size of a planet, completely indifferent to the outside universe. And of course, there's always the simplest, and perhaps most terrifying, explanation. We are alone. After all the calculations and all the speculation, maybe the unique combination of factors that led to intelligent life on Earth, the right kind of star, the right distance, a large moon, plate tectonics, a Jupiter-like planet to shield us from asteroids. Maybe that combination is just so incredibly rare that it has only happened once, right here. So what does this all mean for us, for humanity? The Fermi Paradox isn't just an abstract intellectual puzzle, it's a mirror. It forces us to look at ourselves and our place in the universe. If we are rare or first, it places a tremendous responsibility on our shoulders. We would be the carriers of the universe's only known spark of consciousness. Our future would be the future of intelligent life itself. We would have a duty to survive, to protect this fragile flame, and to eventually carry it out into the cosmos. If, on the other hand, the great filter is ahead of us, then the silence is a warning. It tells us that the path we are on is a dangerous one, a path that many others may have walked and failed to complete. It urges us to solve our own problems, to overcome our self-destructive tendencies, and to work together as a single species to ensure our long-term survival. The future of humanity might depend on our ability to learn from the silence of others. Either way, the search for an answer continues. Telescopes like the James Webb are peering deeper into space than ever before, analyzing the atmospheres of distant exoplanets for signs of life, for biosignatures. Scientists are listening to the sky, hoping to catch that one faint signal that breaks the cosmic silence. But perhaps the most important journey is the one we take right here. By contemplating our place among the stars, we gain a deeper appreciation for our own world and for each other. The Fermi Paradox reminds us that consciousness is a precious gift. Whether we are alone or one of many, our story is still being written. The future is not yet decided. The silence of the universe asks us a question, and it's up to us to answer it. What kind of civilization will we become? Will we be another fleeting whisper in the cosmic dark, or will we become the ones who finally break the silence?
Chapter 6. Passing the Filter.
If there is a great filter, then it's not a wall. It is a passage, narrow, unforgiving, but possible. We don't know how many civilizations reached this point. We don't know how many failed. But we do know this. We are not powerless observers of our fate. We are participants in it. Every major risk we face shares something in common: artificial intelligence, climate instability, nuclear weapons, biotechnology, autonomous systems. They are not natural disasters. They are self-created forces, extensions of our own intelligence. Which means the test is not survival against nature. It is survival against our own capability. For most of history, power was limited by physics. You could only move so fast, only build so much, only destroy within reach. Now power scales digitally, globally, exponentially, and exponential systems punish delay. The great filter, if it exists, may simply be this: can a species coordinate at the same speed it innovates? Because innovation is easy to incentivize, coordination is not. Passing the filter does not mean halting progress, it means steering it. There is a difference. We are already seeing the early outlines of what that might look like. AI alignment research is expanding globally. Climate agreements, though imperfect, are evolving. Nuclear treaties, despite tension, have prevented large-scale war for decades. Biosecurity protocols are strengthening after pandemics. These are not signs of perfection. They are signs of awareness. And awareness is the beginning of restraint. A civilization that survives long-term likely learns three things. First, not every capability must be deployed immediately. Second, redundancy matters more than efficiency. And third, long-term stability outperforms short-term dominance. These are not technological insights. They are cultural ones. For centuries, success meant expansion. More territory, more production, more consumption, more growth. But infinite growth inside a finite system is unstable. A species that survives for millions of years likely redefines success. Not as speed, not as scale, but as sustainability. Imagine an Earth powered entirely by renewable energy. Closed-loop manufacturing where waste from one process becomes a resource for another. AI systems perfectly aligned with human oversight, working as partners, not competitors. Global monitoring systems preventing catastrophic misuse of powerful technologies. And education systems designed for critical thinking instead of division. This is not fantasy. Every component already exists in some early form. The question is not whether it is possible. The question is whether we prioritize it. Artificial intelligence will likely surpass individual human capability in many domains. That is not the end of humanity. It is a design challenge. If intelligence is the most powerful force in the universe, then aligning that intelligence with human values may be the most important project any civilization ever undertakes. This requires international cooperation, transparent research, ethical constraints built into the very architecture of our systems, and patience. Lots of patience. The civilizations that fail to filter may be the ones that rush, the ones that treat power as a race, the ones that confuse capability with inevitability. Survival may belong to the careful. Let's zoom out one last time. 1,000 years from now, 10,000, a million. If humanity survives that long, our current era will be remembered as the great inflection point. The moment we transition from biological evolution to technological self-direction. From reactive survival to deliberate stewardship. Very few species on Earth have shaped the planet consciously. We are the first to understand that we are doing it. That awareness is rare, possibly astronomically rare. If we pass the filter, we may not become a loud, galaxy-spanning empire. We may become something quieter, stable, durable, patient, a civilization that lasts, long enough to witness the slow dance of galaxies. The silence of the universe once felt ominous. But now, consider another interpretation. Maybe the universe is quiet because survival requires quiet. Because civilizations that endure optimize for balance, not broadcast, for longevity, not spectacle. Or maybe we truly are alone. If that is the case, then the responsibility is even heavier. Because if consciousness is rare, then preserving it becomes cosmic work. There is no countdown clock in the sky. No visible barrier marked filter. There is only a series of decisions, small ones. Policy choices, research priorities, cultural values, what we reward, what we regulate, what we rush, and what we restrain. The Great Filter is not a single event. It is a pattern of behavior repeated over decades, over generations. We are early in our technological adolescence. Powerful, impatient, creative, and divided. But also capable of reflection, capable of cooperation, capable of learning from our near misses. The universe will not intervene. It will not punish. It will not rescue. It will simply continue. Stars forming. Stars dying. Galaxies drifting apart, with or without us. And so the real question was never, where's everybody? It was always, what kind of civilization will we choose to become? The universe is quiet. For now.
Thank you very much for watching to the end of this video. If you enjoyed it, please like and subscribe. See you in the next video.